Okay, so today we're doing 10-5. It's on compressions and stretches of functions. So this is just a bunch of kind of a little bit weird rules. We did do a lesson super similar to this in the very beginning of the year, or when I first started teaching you guys, and it's just rules that you really have to just kind of memorize. Okay, so first question, analyze reflections across the x-axis. Okay, so we're graphing f of x equals x squared and then f of x equals negative x squared. So I'm going to graph in pen so I can use two different colors going against everything I teach you. Just never graph in pen, but that's what I'm doing. All right, so let's use purple. I love these magic pens. Okay, so f of x equals x squared. We start at 0, 0, and then we go up 1 over 1, and then up 1, 2, 3 over 1. That's a parabola. That's our pattern, right? Same thing in the other direction. Up 1 over 1, up 1, 2, 3 over 1. Connect the dots. And then we know that this is a parabola, but it's flipped over the x-axis. So let me change to, let's go with green. So we have our first point there, and then we go down 1 over 1. Down 1, 2, 3 over 1, and then same thing in the opposite direction. And there is your parabola flipped over the x-axis. Okay, I'm not going to use green again, that looks terrible. All right, so the try it says write a function with a graph that is a reflection of the graph of f across the x-axis. So all you have to do for this is you just have to put a negative in front, and that flips it over the x-axis. So for this one, it would be f of x equals negative x, and for this one, it would be f of x equals negative radical x, and that flips it over the x-axis. Pretty simple. Okay, next, analyze vertical stretches of functions. So what we're doing is we're taking that function and we're going to stretch it vertically, so it's actually going to become skinnier. Okay, so first, let's graph our parabola. 0, 0, and then up 1 over 1, up 1, 2, 3 over 1. Same thing over here. Okay, this should be like second nature at this point. We've done it so many times. Okay, and then this one, so now this 2 in the front, what it's doing is it's stretching it, it's making it skinnier, so I'm going to do this in blue. Okay, well the blue doesn't work. Oh yes it does, okay. So instead of going up 1 over 1, I'm gonna go up 2 over 1 now. And then instead of going up 3 over 1, I'm gonna go up 1, 2, 3, 4, 5, 6 over 1. Same thing on the other side. Instead of up 1 over 1, up 2 over 1, and then up 1, 2, 3, 4, 5, 6 over 1. Voila, makes it skinnier. Okay. So for this, write a function with a graph that's a vertical stretch. So what we can do is for this one, we could just put any number in front of it that is greater than 1. So let's do like 2, that's fine. For this one, it's got to be on the outside. So you could do 2 again, 3, whatever you want. Any number that's greater than 1. Okay, now let's do this. All right, so now we're doing vertical compression. So now what's happening is we are squashing the graph like this, and when we squash the graph, it's going to become wider. Okay, so vertical compression. So we have the absolute value of x, and then we have 1/2 times the absolute value of x. We have a fraction in front. So we will first start off with graphing the absolute value of x. Remember 0, 0, and then we go up 1 over 1, up 1 over 1. Keep going up 1 over 1, do the same thing on the other side. Okay, and then for 1/2 x, instead of going up 1 over 1, we're going to go up 1 over 2. Up 1 over 2. And that's going to make our graph wider. Up 1 over 2 in both directions. Okay, so now write a function with a graph that is a vertical compression toward the x-axis. So as long as you multiply it by something less than 1, you're fine. So So we'll go 1/2 x. For this one, let's change it up. Let's do 0.3. Remember, you can use fractions or decimals because that's the same thing. Radical x. Okay? All right, so now horizontal stretches of graphs. So this is like different, like the rules are basically the opposite. With a horizontal stretch, we're taking the graph and we're stretching it horizontally. So we're going to start off with graphing f of x equals x squared. So that's our parabola. Start at 0, 0, go up 1 over 1, up 1, 2, 3 over 1, and then same thing on the other side. And then for this, so the 1/2 is not getting multiplied in the front here, it's just getting multiplied to the x, and then you square that whole thing. So it's a little bit different. So I'm actually going to make a table of values for this to graph that. So let's do the values -2, -1, 0, 1, 2. So if I plug in -2, -2 times 1/2 is -1, and then -1 squared is +1. If I plug in -1, -1 times 1/2 is -1/2, and then -1/2 squared is +1/4. 0, 0, plug in 1, that's 1/2 squared, so that's 1/4, and then plug in 2, 1/2 of 2 is 1, squared is 1. Okay, so now I can graph these values. So -2, 1, -2, 1 is here. -1, 1/4 is right about there. 0, 0, 1, 1/4, and then 2, 1. So it's a parabola that's going to be wider than this one. And once again, that is because we are stretching the graph horizontally. So now we're going horizontally, we're stretching it, so that's what's making the graph wider. Okay, so now write a function with a graph that is a horizontal stretch. So when you're doing anything horizontal, it's only going to affect your x value here. It's only going to affect your slope. So we can do f of x equals 0.5x plus 1. Anything less than 1 will work, and you only want to multiply it to the slope. For this one, you have to make sure you're multiplying it to the inside and not the outside. So f of x equals, let's do 0.3x, just picking a random number, less than 1. Okay, example 5. Now we're doing horizontal compression. So with horizontal compressions, we're taking our graph and we are, from the horizontal direction, we are compressing it. So when we compress it, that's going to make our graph nice and skinny. Okay, so first, f of x equals x squared. So we're going to do 0, 0, up 1 over 1, up 1, 2, 3 over 1. Same thing on the other side. So we have our parabola. I'm going to make a table of values to graph this other function here. So we're going to go x, y, -2, -1, 0, 1, 2. All right, so if we plug in -2, -2 times 2 is -4. -4 squared is +16. -1 times 2 is -2. -2 squared is +4. 0 times 2 is 0. 0 squared is 0. 1 times 2 is 2. 2 squared is 4. 2 times 2 is 4. Squared is 16. I'm not going to graph these values because they're going to go way off the graph. I'll start with these values right here. Okay, so we're going to go -1, 4. So -1, 1, 2, 3, 4. And then we have 0, 0 right on top of that value, and then 1, 4. And as you can see, that's making your graph skinnier. Okay, so write a function that is a horizontal compression of the graph. So with horizontal compressions, it's different than vertical. You want a value that is greater than 1. And so we're going to do, let's do f of x equals 3x squared. You have to put it in parentheses. And then for this one, we'll do f of x equals, make sure it goes under the radical, 4x. Okay, so let's just like kind of review some of the rules. This is going to help you with your practice problems I assign. Describe the transformation from f of x equals x squared. So if we have f of x equals negative x squared, that is reflected over the x-axis. Reflected over x-axis. If you have a 2 in front, so that number is greater than 1, and it's multiplied by the entire thing, so that would be a vertical stretch. For this one, it's multiplied in the front here. It's less than 1, so that would be a vertical compression. For this one, if it's inside the parentheses, that means it's going to be horizontal. And since this number is greater than 1, it's a compression. So it's like opposite of the vertical. Okay, and then this one is less than 1, and it's on the inside, so it's a horizontal stretch. Okay, let's look at this. This is a linear function here. Describe the transformation from f of x equals x minus 2. So, for this one, as you can see, there's a negative in front, and that negative gets distributed all the way through. That's why it changed to a positive, okay, because we distribute the negative all the way through. So that is reflected over x-axis. Okay, for this one, the 2 in the front is going to affect the slope and the y-intercept here. It's going to get multiplied through by the whole thing. So we know it's going to be vertical. And since this value is greater than 1, it's a stretch. For this one, it's getting multiplied through by the whole thing, once again, affecting the slope and the y-intercept. And it's less than 1, so that means it's going to be vertical compression. For this one, it's just affecting the slope. This 2 is just affecting the slope, just multiplied by that x value. So we know it's going to be horizontal. Horizontal. And since this value is greater than 1, it's a compression. So it's like the opposite of the other ones. And then for this, the 0.5, that is less than 1. And it's just getting multiplied by the x value, the slope, so it's a horizontal stretch. So you can use these 2 problems are going to help you a lot, I think, with your homework that I assign. So refer back to them. Okay, that is it. Have a good day.